In this video, we are going to talk about the Unit 1 test review. We're going to start out with talking about the three types of 3D figures, the views that we look at. We have the 1-point perspective, and when we're talking about perspective, we're talking about viewing something from eye level. Okay, so for example, on this one, this is called a 1-point perspective. Okay, that's saying, pretending like these are your feet, right? And you're standing right here. This is you. It's one little stick figure. Um, so you're standing right here and you are looking straight past this box, okay, to this 1 point. So you're looking at this front face, all right? That's called a 1-point perspective, okay? A 2-point perspective is when we're looking at the edge of a figure, okay? If you look at the edge of a figure rather than the front, then you're going to see lines that go in two directions, okay? So this would be a 2-point perspective, and this one we have two vanishing points, and this one we just have one vanishing point, okay? When we're talking about a 1-point perspective, just a second, I'm trying to erase this. When we're talking about a 1-point perspective, all right, this is going to be the top face, and then you'll have the bottom face, which we can't really see, okay? The depth of the cube is from front to back, so this edge right here would show the depth, these two edges, and then this edge, and then that hidden edge that we can't see back there, that would be the depth, okay? An isometric drawing is just a drawing that does not have to do with perspective. We're not looking at it from eye level, we're just drawing the shape. So those are your basic three perspectives. So on this, we're going to view these and we're going to decide if it's a 1-point perspective or a 2-point perspective. Okay, on this, okay, we're looking straight on at this figure. See how all the lines go this one way towards this 1 point down there, right? That's our 1 point that we're looking at. Okay, so this is a 1-point perspective. If we look right here, this would be a 2-point perspective, because see how our lines are going in two different directions? Okay, now they're all headed towards these same points, but in two different perspectives. So that's a 2-point perspective. Okay, this house down here, this bottom house, this is a 1-point perspective because we're looking at it straight on, right? All of our lines are going in the same direction. This one, we're looking at the edge of this building. Okay, see this street right here? So that's going to be a 2-point perspective because our lines are going in two separate directions. Okay, when we're viewing an isometric drawing, we can view it in 6 different ways. Okay, we call these orthographic views. This is the left view. This is the right view. We're viewing that one rectangle. The front view is that shape right there. The back view, right, is just opposite of the front. The top would be these 3 rectangles, right? Well, they get bigger, so 1, 2, 3, and the bottom view is just the one on the bottom that is the full rectangle. Okay, when we have lines on 3D figures, we have 3 types of lines. We have parallel lines. Okay, these are lines that don't intersect, but they can be contained by the same plane. See, both of these lines are contained by that plane. Intersecting lines are lines that do intersect and can be contained by the same plane. So see, look, these lines are both contained by that plane. Skew lines are lines that don't intersect and cannot be contained by the same plane. Okay, because if we look right here, this line is contained by this plane and this plane. Okay, but this line, I'll change my color here. This line is contained by this plane and this plane over here. See, so neither one of these lines are contained by the same plane. So we call those skew lines. Okay, a dihedral angle is an angle formed by 2 non-coplanar half planes and their line of intersection. Okay, quadrilateral ADIJ forms the dihedral angle with ABCD. Okay, see, this is the angle that it forms right there. Okay, so just imagine that, this is a tent that has fallen over, okay? And this is the top part of the tent. That's the dihedral angle. Okay, so in this one, it says in the rectangular prism, okay? That's important to know because that tells us that it's a right angle. When we have a rectangular prism, it says that angle EAJ has a measure of 32 degrees. Okay, what would be the measure of the dihedral angle that is formed by plane ADIJ and ABCD? So the dihedral that we just talked about earlier over here. But we want to know the dihedral, so that angle right there. Now, since we know it's a rectangular prism, it's a right angle, we know that this big angle is 90 degrees. So in order to answer this question, we're just going to take 90 and we're going to subtract it from 32, which is going to give us 58 degrees. So the dihedral angle is going to be 58 degrees. Okay, definition of a polyhedron. Okay, a polyhedron is a three-dimensional figure whose boundaries are polygons. Okay, remember anything that has polygons. Remember, a polygon has to connect at the endpoints and it has at least 3 edges. Okay, so this would be, all of these would be examples of polyhedrons. We classify polyhedrons according to their number of faces. Okay, so here this is a tetrahedron. It has 1, 2, 3, 4 faces. This has 5 faces, 1, 2, 3, 4, 5. So it's a pentahedron. A 6 is a hexahedron. We call that a cube, right? 1, 2, 3, 4, 5, 6. A heptahedron is 7. Okay, so we have 1, 2, 3, 4, 5, 6, 7. And then an octahedron would be 8. 1, 2, 3, 4, 5, 6, 7, 8, right? The 4 triangles on top and the 4 on the bottom. Okay, and obviously these go on, but these are the main ones that we'll cover. Okay, the net is just how the 3D figure would look if we unfolded it. So really when we're looking at nets, like when we're trying to match nets to their polyhedron, what you want to do is look for the shapes and the number of faces, right? So if we look here at this, it has 1, 2, 3, 4, 5. So this is a pentahedron. Okay, it has 1 square and 4 triangles. So that's what we're looking for on the net, right? Here's the 1 square, and then it has 1, 2, 3, 4 triangles. Okay, then the number of shapes has to equal the number of faces whenever you have the net and the solid. Okay, so on here we have this cube. Okay, it has 1, 2, 3, 4 rectangles and then what looks like 2 squares. So if we look here, 1, 2, 3, 4 rectangles and 2 squares. So that would be its net. Okay, a prism now is a polyhedra or a polyhedron with 2 parallel congruent faces called bases. Okay, so a prism is a more specific polyhedron. Now, when we classify prisms, we classify them according to the shape of their bases. Okay, so for example, the base here, the 2 parallel sides are rectangles. So this is a rectangular prism. Here, the 2 bases, the ones that are parallel, are triangles, so it's a triangular prism. Here, the 2 bases are an octagons, so we call it an octagonal prism, okay? We could classify these as polyhedrons as well, but remember, polyhedrons has to do with the faces. So a rectangular prism has 1, 2, 3, 4, 5, 6, so this is also a hexahedron, okay? This triangular prism has 1, 2, 3, 4, 5 faces, so this is a pentahedron. Okay, so do you get the point there? All right, you can classify them as 2 different ways, but when we classify the prism, we're classifying it according to the shape of the base. So here it's going to ask how many edges does each prism have? Okay, so here we have a rectangular prism, and if we notice we have 1, 2, 3, 4 sides, right? And then we have 4 more edges, 1, 2, 3, 4, and then 4 on top. So this has 12. Okay, here we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So do you notice a pattern here? Right? When the edges of a prism, just however many sides the base has, right? 1, 2, 3, 4. You're just going to multiply it by 3, right? Because you have the lines that go up and then you have the same shape on the top. So it has 4. 4 times 3 is 12. 3 times 3 is 9. 8 times 3 is 24. When we classify diagonals of a prism, we have two different diagonals. We have the face diagonal and a space diagonal. The face diagonal is the diagonal that goes across the front face of the prism. The space diagonal is what goes in the middle of the prism from one edge on the front to one edge on the back, okay? Or one edge on the back to one edge in the front, but it has to be bottom front or back to top front or back. So when we find the lengths of the diagonals, right, these just make right triangles, okay? So if I was going to find the length of this space diagonal that goes from A to B, okay, it would just be G squared plus H squared equals D squared, okay? But a lot of times we're not given this information, the G part, okay? So what we want to do, okay, is first find this triangle down here, okay? And the way we would do that is we would say L squared plus W squared equals G squared. So now all we have to do is take that and plug it into G squared. L squared plus W squared plus H squared equals D squared. Then we just take the square root of everything. So if you want to find the space diagonal, all you have to do is find the square root of length squared, width squared, and height squared, and that will give you the length of the space diagonal. So for example, if I want to find the length of this blue space diagonal right here, okay, remember we're using the square root of length squared plus width squared plus height squared, and that's going to give us D, the space diagonal right here, okay? So I'm just going to plug in these numbers right here. We're going to say 5 squared plus 8 squared plus 6 squared equals D. 5 times 5 is 25. 8 times 8 is 64. 6 times 6 is 36. Add all of those up together. That's going to give us 125. Take the square root of that. And that's going to give us, and here it says round it to the nearest hundredth. Okay, so it's going to be 11 point, and it says 11.180339, so 11.18. So D, the length of this diagonal, is going to be 11.18 centimeters. Okay, find the surface area of the prism. Okay, remember that our formula is P, the big P stands for perimeter of the base. H stands for the height of the prism. Okay, the height of the prism is what connects the two bases. And then B stands for the area of the base. Okay, remember we measure surface area in square units. So it'd be square centimeters, square inches, square millimeters, square meters, etc. So here we want to find the surface area. So we're going to add up the perimeter of the base. Okay, so 6 plus 12 is 18, and we know that's going to be the same on the other side. Okay, so we're going to have 18 plus 18, which is 36. We're going to multiply it times the height, which is 2, and then we're going to find the area of the base, which is 12 times 6. So that's going to be 72. So now we're going to take 36 times 2, which is 72, and then we're going to take 72 times 2, which is 144, and we're going to add those up together and get 216 meters squared as our answer. Okay, for this one, same formula, only now our base is a triangle. Okay, so find the perimeter of the base. All right, now the base here is the triangle. We've got to find this hypotenuse. Okay, so what we are what we are going to find first is this hypotenuse right here. So we can use Pythagorean theorem. So we're going to say 9 squared plus 12 squared equals c squared. Okay, so we have 81 plus 144, which is 225. So we're going to take the square root of that and get 15. 225. So c equals 15. Okay, so now we're going to add up the base. 15 plus 9 plus 12 is going to give us 36. We're going to take times the height of the prism, which is 15, plus 2 times the area of the base. Okay, now remember, our base here is a triangle, so we're going to use 1/2 and then 12 times 9, which is 54. So 2 times 54. So now we're just going to add all these up together. 36 times 15 is 540. 2 times 54 is 108. And then add those up together, and you're going to get 648 centimeters squared as your answer. Okay, the volume of a prism. Okay, remember volume is big B, which is area of the base. H is the height of the prism. We measure volume in cubic units, so cubic centimeters, cubic inches, cubic meters, cubic millimeters, etc. So we want to find the volume of a prism that has a base area of 50 centimeters and a height of 15 centimeters. So B stands for area of the base, so we already have that, which is 50, and then times that times the height. So all we have to do right here is take 50 times 15, and that's going to give us 750 centimeters cubed. Here I'm going to find the volume of this triangular prism. Okay, so volume, we're going to take the area of the base. All right, so area of the base is a triangle. So we have 1/2 base times height. So we have 12 times 5, which is going to give us 30. And then we're going to take it times the height of the prism, which is 10. So our volume here is going to be 300 centimeters cubed. Okay, if you are in Geometry 202, then you can cut out now. You don't really need this example, but if you're in 203, you do need this example. So if you're in 203, stick around for this last one here. This says the following is a diagram of the top view of a right hexagonal prism that is 10 centimeters high. What is the volume? Okay, so this, we're looking straight down on a prism. So there's lines that are going straight down, and there's another hexagon at the bottom. Okay, so we want to find the volume, which is the area of the base times the height. So if this is our base right here, okay, then this would be a hexagon. Okay, now remember, when we're finding the area of a hexagon, we're going to use 1/2 times the apothem times the perimeter. Okay, so we're going to take the perimeter here, right? We have 6, means we have 6 on each side. That's 36 if we add up all the sides, and our apothem is 3. So we're going to take 3 times 36, divide that by 2, and that's going to give us 54. Okay, so our volume here, the area of the base, is 54. Now it tells us the height of the prism is 10 centimeters, so that's going to give us a 10 right there. So our volume is going to be 540 centimeters cubed. And that is the end of Unit 1 test review.